Welcome everybody, thanks for attending this event online, and it is our pleasure, it is our privilege to have Liran Tal with us today. He will be talking about weaponizing NPM packages for various evil reasons, so we're going to learn a lot about that. So thanks a lot Liran for being here, thanks a lot all of you who are attending as well in person. We've got quite a few people who came to Node Ipc 6 in Zurich. So without further ado, Liran.
All right, I'll go ahead. And please ask any questions on the chat. And this is like very interactive also here. So please, just go ahead, stop me if it's unclear. You want to just elaborate more. So yeah, weaponizing open source software in general. I'm coming from the JavaScript open source ecosystem, the Node.js one. I've done a bunch of things on the ecosystems, like working with the Node Foundation before it even transitioned to what it's today, the OpenJS Foundation. I've had some work as the OWASP project, which is the Open Web Application Security project for security and developers today. So I've done a bunch of all of this, GitHub Star as well, and at Snyk I am a developer advocate, which essentially means I'm kind of like, my mission is to work with developers and help them be successful at building a secure project, writing secure code, all of those kind of things. So a lot of this is really awareness sessions like this. A lot of this is also for me. I do a lot of security research because I really like that area. So I do that. I read a lot of security academics research, which will touch some of them here as well, and kind of like highlight and do a lot of education. Yeah, so that's about me a bit. Get up and running with some stuff. So what I want to show you today is some stories about what's happening on one of those open source ecosystems, JavaScript, which I know a lot of Java people and people from more, let's call it structured languages might look down at it. But it's really like, dominating the web in different ways, right? Like the front end, the browser, but really just server side in all kind of like ways. And so developers really play a key role in this open source ecosystems, however you look at it. We use a lot of open source tools. I use VS Code, it's an open source tool. Like if something goes bad there, which maybe it did, like we'll see today, then it impacts me as well as millions of other developers around the world. And essentially a lot of issues here that we'll talk about are really about the supply chain security. It's like how all of those stories kind of like relate to us. So my next slide is, I think a lot of people can emotionally relate to this. Essentially because like this is, I had to edit this meme specifically to get that, but I feel like when we kind of want to go and like install that, that bomb file, that Ruby gem, that NPM package, it's like, should I do it? Should I not do it? What happens if I do it? What kind of stuff does it bring in? Many other packages. I'm not even talking about vulnerabilities that it may have, like just whatever it may do that could be malicious. So yeah, if you feel like that, I totally relate, and I want to tell you like it's okay to feel like this. Like you should be worried of what you install, and that means you have like a good, healthy awareness level in terms of understanding the risks of being, part of open source. We'll get to this. But essentially, the scientific, if you want, the scientific proof of like why you might be feeling like that sometimes is some ideas like this. For example, one academic research that I read a while back, said that if you install, the average NPM package, you essentially put trust on something like almost 80 other maintainers, right? Like almost 40 other NPM, other packages that you get, and you get them transitively. They're not always like a directory, they're nested trees and so on. So it's a bit of a convoluted, Wild West kind of world where it's part of the beauty of open source, but also to understand that when we install something, it's not just the specific thing. But also it's, I think the understanding, the realization that today when we build software, which I think is, unlike about 2 decades ago, which was, file new, start from scratch, you write a code, everything, etc., include stdio, C, all of those kind of things. Today, you actually start off essentially with using generators. You generate a project based on specific, things that you need. You have frameworks and, Spring. You don't reinvent the web. You actually go ahead and use that. And it makes sense, but you need to be aware of it. And if you think about NPM and how much you can reuse, the last official figure that I took from NPM was like almost 2 million packages, which I'll shoot for an interesting poll, which is how many of them do you think could be considered abandoned on NPM as a ratio if the criteria to say that is that they didn't have a release in the last 12 months? Go ahead and give me some ideas. 20%, 90%, where does it go? 75?
80.
Okay, 80. Okay, that's also good. What else? 98. Oh my God, we found the person who doesn't believe at all in open source. No, I relate. Okay, that's also a good answer. Want to try? No? Okay. It's about half. It's about 61% packages did not have a release in the last 12 months. And potentially could be considered abandoned. And there was like stories of like how one of those packages, event stream, really was like part of those like 61% and essentially had a malicious act around it, and was, you know, it is millions of downloads of downloads of that package that actually indeed ended up releasing backdoored software that made it into the app stores. Like, that's like a crazy thing, but it did happen, and it did happen for a package that indeed wasn't maintained for like the last year. So, you know, these are parts of the stuff that we're saying. So let's talk about like, how do you weaponize open source software? Like, what are the ways of doing them, understanding the risk, you know, supply chain security, you know, cloud native, how does all of that connect together? So one of them is typo squatting, which is a very, you know, familiar case of attack that we've seen. By the way, works on other ecosystems. We've seen that on Python, we've seen that on Ruby gems, all of those other ecosystems, they have the exact same issues. Essentially, it's like domain squatting. Someone, instead of using, you know, if you want to install CoffeeScript as like one of, you know, popular NPM module from like a while back, and if you misspell it, if you put a dash where there's no supposed to be a dash, you essentially get a different package. Because NPM is an open ecosystem, and many of those other registries are as well, you could just install someone else's package, which once you install it, does malicious things. So this has been like, you know, won't go deeper into this because this has been like very, you know, kind of drilled all the way around in terms of like what happens. It's a risk, just, you know what you install. The other one is compromising maintainer accounts, which is a bit of a frightening thing, because if you think about it, maintainers are just developers. You know, like me and you, they make some mistakes in code, but also in the way that they treat security. So like their security hygiene might not be the best, which means some past research on this field had actually yielded some really interesting results. For example, how many people here know the project called React? There you go, some people know it, cool. Express, web application from, cool. What if I told you to both of them, someone a few years ago, to both of those projects actually received publish access to publish new versions of those modules? It's a bit insane, right? Like React, if you know it, Express, if you know it, it's pretty popular projects. If someone, malicious actor, gets access to that, that's basically game over on the ecosystem. Everyone installed the new packages all the time, and that's it. So it really did happen. But luckily to us, it was a person who was working with a technical steering committee on the Node.js Foundation project. And they actually went in and did kind of like an ethical hacking NPM credentials study, right? Like they try to like learn why they actually find leakage of you know, former passwords that maintainers might have used, and this is how they found it. They reported all of those findings, of course, to NPM and those the package owners. So, of course, the maintainers that they got access to, you know, sometimes they use their password like 1, 2, 3, 4, 5, like literally the word password. Sometimes, you know, in some of those cases, maintainers use their password that was previously leaked in like a different data breach, and they only added like a character to it at the end of it, and like they were able to find this and again gain control of the package. So all of those things, they were done by a person who actually cares for the ecosystem and found them, but might have well have been done by someone else who didn't. So like it shows you how like all of this, you know, compromised maintainer is a thing, even for like big, very, very popular you know, packages. It happens because we don't enable 2FA regularly, we don't choose right passwords, all of those cases. There's been some recent research, not just about compromising maintainers, in a different way, which is also super interesting. Like the fact that I, for example, might use, like if I have a domain called example.com, which is my domain, and I might use that as my maintainer account when I sign into NPM, and not my, for example, Gmail or Hotmail or whatever, then potentially after some times, maybe I'm just not on the ecosystem anymore active as a developer, and that domain might have expired. So this research showed that people were able to actually gain access to maintainer accounts from the fact that they have just re-registered some weird domain name or whatever that just expired. They own it. They can do a whole reset password kind of thing with NPM and get access to all of those packages. There's a lot of cases where they're like just packages on NPM for like 10 years, since 2011 or so. And they've just been there, like super popular, like millions of downloads, and they just work because they've been on the ecosystem for so long. Everyone just depends on them. The maintainers have like continued to like different things. Again, another driver of like how you could like compromise maintainers. And this is like a research from like a few months back. So super interesting, but also scary of like how people actually compromise us, and that's all of us. More issues that we've seen, malicious modules themselves, so people just plainly put malicious code on NPM. Snyk had an interesting story where we found a case of dependency confusion, which I'll get to at the end in terms of like how to protect against it, and we'll talk about maybe what it is briefly. But we found cases of dependency confusion at Snyk recently. There was a blog out, etc. But like 2 weeks ago, and we honestly thought like they are targeting an actual specific company. So we couldn't tell who it is. We thought this was like a real thing. We caught them red-handed and all of those things. And they really did target a specific company. I think it was a German company. As we were kind of like, reporting the IP address to, I think, Heroku or DigitalOcean, one of those where it was hosted on, reported it to NPM, etc. And like at the end of it, kind of like, a week or two later, they kind of like went out public and say, hey, you know what, Snyk, found us, and those threat actors were actually a security company. They were doing external kind of like pen testing and testing the company. So it's incredible what happens on the NPM registry, plus the fact that we were able to like find those people. Like luckily, again, for everyone here, like that company had like being pen tested and not something really malicious, but like super, super, I don't say bad, but like super dangerous to just be in this kind of situations. So there's that. Social engineering, we've seen that with a few cases. Event stream, I repeat that story a lot. So like if you want to watch like prior talk, or like just view the Snyk blog, there's like an interesting postmortem of like what happened there. It's a story from 2018, how essentially one person just got access to a repository and a very popular package on NPM, like 2 million downloads or so a week. And did that by like just socially engineering their way, like trying to help. As they were trying to help, the maintainer who maintained like 500 other modules just gave them access because it's open source and people want to help, so you can like empower them. But they were a threat actor, and they added like a backdoor to a cryptocurrency wallet, and they targeted a specific team. They did a really good reconnaissance job of like how that other team that they targeted with that backdoor, like how does the build work? They use Webpack and they use event stream, and they kind of like backdoor that one. Like there's like a whole really interesting deep dive into it. I think I like that story because I think it's a very interesting attack that someone like we don't know who it is today, but there's like a group of people that specifically spearheaded a specific team in open source, and also was able to like actually do that because that team that built that cryptocurrency wallet, they've actually released 2 versions with that backdoor that kind of stole Bitcoin from, I don't know, some other cryptocurrency thing from people. So super interesting. But again, these are the dangers that we learn about afterwards, and it's always good because at least we can be aware of them in the future. So all of those are like really, I would say low-hanging fruits for people to weaponize open source. So we talked about dependency confusion just a bit with like the reference, and we'll get to it later. But what I will want to get to more, which is like what happened really recently, is what I call, or what other people have actually called protestware, as well as fundware, which is an interesting case of what's been happening recently. So let's talk about Faker.js. That's an open source package that basically allows you to generate massive amounts of random data, kind of like faking stuff, like stubs and tests when you weren't running that in CI and whatever. Developers use this, and instead of like just making up names or whatever, they just use this, and it feeds names, phone numbers, whatever. It's like has locale support. It's pretty cool to like do help support your test framework. It's fairly popular. You can see a lot of other projects that are very known, like Nuxt, Viewfront are using it. Very popular projects. But one day, okay, this is January 2022. One day, not so long ago, you open the repository of this very, very popular package, and this is what you see. Okay, this is January 5th, 2022. Some things kind of like are really interesting here. First of all commits with end game message. 5 days ago, there's really just one single commit in this repository. Someone forced push all of this code, which if you look inside kind of like has nothing interesting. There's no code anymore. There's nothing. There's just some kind of like dummy data that doesn't really do anything, and that's it. And the moment you see it, you're like, well, what's going on? Okay, let's go to NPM, check what's going on with the package. Like this is the repository, there's the package for it. Okay, so you open NPM, like this is a very popular project, like I said, like 2 million downloads a week. There's like some packages from 9 months ago getting a decent amount of download just in the past week, but there's this new package, new version, 6.6.6, which is already kind of like flagging. People get like red flags. What is going on? Published 5 days ago. A bunch of people already got hurt by this, right? 1,200. Then you're like, what? What is 6.6.6? It looks like a joke. What's going on? But then you actually realize everything, all the functional code from Faker was actually removed in version 6.6.6. So if someone had installed it for some reason, usually automated upgrades, or like when you do npm install, just fetches like the minor or the patch version. It doesn't do like major upgrades unless you like explicitly use a wildcard or latest or whatever, which is a bad practice. But still, like this, we saw before, 1,200 people have actually been hurt by this. So you're like, what is going on still? And like, okay, something is going on. So what is going on here? Back in the day, about a couple of years back, before all of this happened, the maintainer went in and said, no more free work. This is like a really popular project. It's being used by a lot of Fortune 500 companies. They do not pay me back. I am essentially working for free, voluntarily. A lot of developers in your Fortune 500 companies use it to build your $1 million products, but you're not giving anything back. And you could see like you can't read it from there, but like there's like 2,000 thumbs up versus 25 thumbs down, right? Like people relate to this. People understand the struggles that maintainers have, that they're unsustainable development, that they work a lot of after hours work, weekend. They kind of like really help. They make the ecosystem thrive by spending a lot of their time. They're not really getting a lot of things back. The amount of people, of developers, of maintainers that are getting like sponsored on GitHub or sponsored via Open Collective is like super small amount of them. And if you actually dive deep into like seeing how does that actually work, you'll see some very high profile maintainers that get some funding, some money from companies, and what they actually do is they themselves fund other maintainers. So it's a really unbalanced game between open source and corporations. And look, I don't need to tell everyone, because I know you all know this, but this person decided to take an act, okay, and like stop doing this. So he said this November 2020. This is like a while ago, before he did that other what we just saw, right? The whole nullifying thing here. So this happened. And then you're kind of like, okay, if this happens like tomorrow morning for a project that you use, like maybe it's Faker, what you could do, you could fork the project, like it's open source, you have like, history, you could just fork the project and that's it. You could pin your dependencies, so like, you'll never upgrade to like 6.6, whatever, that major version, because it's broken, so you can still use the old code. And it doesn't break your production, like until you figure out migration plan or whatever you want to do. But so these are like way to like mitigate or work around it, but what you're missing is something else. You're essentially missing the fact that this is a maintainer that potentially has other modules that maybe you're using them. And if he did that to one module, what stops them from doing this to other modules that you might be using? So remember Faker 6.6.6, broken code, doesn't work, functional code removed. 3 days later, after this case, we've got this. Colors. It's a very, 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 very popular package on NPM, one of the most downloaded ones, tens of millions of downloads. Colors is very useful for a lot of terminal and CLI apps and whatever you use to like just color text on the terminal. And maybe you even want to use it as a like it's being used immensely as a transitive dependency that you probably you install it, just don't know it. But if you want to install it directly because you build a CLI or whatever, you want to build a generator for your team, like a platform development team. So you go ahead and you want to do npm install colors, but this is how you feel, right? You relate to this again. It kind of haunts you because you've heard about all of these stories, and the next time you'll do an npm install, before you press the return key, you'll like think like 5 times before you do it. And again, all of that is very, very, very correct and justified. It's okay. It's okay to be scared from this, because if you had installed npm install colors as is, getting the latest version or the latest stable version of that branch, you'd essentially get the following. This is a for loop that runs through infinity. It's a code that has been added to the latest minor, we'll see in a second, but I think it was the minor version of colors. The moment that any program just uses colors behind the scenes to color something onto the screen, this infinite loop runs. I've just removed a bunch of stuff from like what it prints, which we'll see in a second, just so like you could see the actual thing. But this is the real code. I just like made it a bit smaller. This is what happens. It says liberty and whatever and zalgo blah blah blah, and this is what you see if you had used this in one of your if you were kind of like part of this attack. So how did this happen, and what was the impact? Like, we're talking about this, but what's the impact? So here it goes. First of all, 2 years ago was the last version of 1.4.0. It had 14 million downloads the last 7 days when I took that screenshot back then. Okay, these two versions, just a day, okay, within the 24 hours when they got released, they already impacted 100K users or downloads. Right? The moment that this got released, a lot of CIs and builds and automated, and people just do npm install colors or whatever, they get it in some way, fetches latest, I said minor, so it's a patch version, and get it, and that's it, right? At that moment in time when colors is then kind of used within like the system, the function called flow to like use colors, that's it, it's game over. This is what they get. And that's what a lot of people came into a lot of forums afterwards and said, hey, I'm getting this stuff when I install your project, which they have no idea what to do with this. So again, you're thinking, I'm not using it because I know I'm not using colors directly, but I may have other packages that call it and use it for me. And like, let's take a look at some of those packages. Maybe you'll recognize some of them. AWS CDK uses colors, and everyone who uses that got it. Prompt is a CLI thing to prompt you interactively, uses it. Playwright, it's a web testing thing from Microsoft, uses it. Cucumber, again, more examples. So there's like, the list is on and on. It's like 50,000 projects depend on this. I just try to like find some that people might know more, but a lot of people have dependent on it, and they got this, got the impact of like that denial of service to a specific amount. You could see like the amount of projects that were directly dependent on it versus indirectly. So like, that's really meaningful. So this brings us to like talk about, well, what's this thing open source activism if we're seeing all of those things? So activism is more about promoting open source software, collaborating, doing fixes, doing proposing a pull request. This is like taking part in open source, but that is different from open source hacktivism, which is more about taking political stands and doing something about them, like doing some hacking for human rights, hacking related to free speech, movements of different things, and so on, right? Hacktivism is something else. Now, how did we jump? What was that moment in time when we jumped from open source activism to open source hacktivism? Which is like, why are we even talking about this? It's like so far away from like what open source is, maybe, I don't know. So why are we talking about this? Because 3 months later after those incidents of faker and callers from one specific maintainer, we have another incident that's like really interesting and somewhat current to the current affairs. And that is the Node Ipc incident. I did not know about this module before this thing happened. It's you know, some inter-process communication thing which I've never used myself. Pretty sure a lot of people haven't really used that or whatever. But again, it's one other popular module that gets used by some other, you know, top-level direct, I don't know, Electron or Vue things, SDK, whatever that they use. And so it's fairly popular. You see 5 billion downloads. Yeah, added as an indirect package. But then the maintainer had actually sabotaged it to make a point. The point, of course, they were trying to make in that case, which I haven't like, except for the title, I haven't like touched it. But essentially, they were trying to protest against, you know, the Ukrainian-Russian, you know, crisis still going on. This was March 2022, so this was like very in the heat of the moment of, you know, when things kind of like were, I think, to this point, like even more in the news. But let's take a look at what happened here. Like, let's figure out what's going on. So again, July, October 2021, packages, you know, released, nothing new, 10.1.0 and so on. March 7, 2022, something new gets released, 10.1.1. 10 is the next stable version branch of Node Ipc. So most projects that are popular and have been hit by this actually use the 9 major version. 10 was back here even, had of course like, you know, fixes, features, whatever, but it also introduced one of the like the breaking changes here. It actually introduced ESM support for JavaScript. So this 10 version didn't have many downloads, but it had definitely some considerable, you know, thousands of downloads by users. Here is part of the code that got added on March, version 10.1.1, okay? One, you know, bright day, this is what's happening. So if you look at the GitHub repository and like you're like, well, let's look at what the code is doing, you know, the change log, this is part of it. This is literally what you see. This is not like transpiled code from the package when it gets built. It looks like some transpiled or like uglified code, but on GitHub, on like the actual source code that, you know, people actually like, this is supposed to be readable and maintainable, but it's really, you know, doesn't look like it, to me anyway. So here's the change log. We'll go through it together and we'll see what's happening here with Node Ipc. So you look at this, you look at the diffs, and it looks like, you know, it imports something from the file system. Not really sure why it needs to do that if it's like Node Ipc thing. It does some random stuff, and you see buffer from, there's some string that you don't see the end signature, but that's basically a base64 thing. And you're like, okay, weird, but let's continue of what's going on here. And this is the rest of it. This is how it continues. So there's some timer in there, which is, again, weird, but it happens. Here's that base64, and more things that are base64. And the first thing that you do if you see this kind of code somewhere is, besides running away from it, yeah, you probably want to base64 decode it, right? Just see what's going on there. So okay, so you see, let's decode the first one. It goes to, again, these are like, think that you're like looking at it for the first time. This is Node Ipc. You look at the source code, you found it. This is like super weird, okay? You're saying some IP geolocation stuff, and apparently there's like an API key there. Like if you look at it from like the security person's eyes, like, they hard-coded the API key, you know, maybe it's funny, let's laugh about them, whatever, which they did for this whole thing to work. But it's not the only thing that kind of like captures the eye. So you go on and like, okay, this is also base64 encoded. Any guesses what these are? Yeah, any guesses? YouTube?
Language codes.
Language, okay, close. What is it?
Countries.
Countries. Okay, close. It does something with countries later. Okay, it's not that obvious. Of course I had to basically decode it myself as well. So you'd see this and it's like super weird, and like you decode it and not just path reversal. Wait until you see what's going on here. This is within a function. So paths on the file system, but essentially all of them, and there was a bunch more which I also cut from this because it was like too long as like the malware code here, but like file path stuff. So why does Node Ipc need to do all of those stuff? Again, like maintainer just woke up one bright day and said, I'm pushing this code to GitHub, and then like 24 hours later 100,000 people get this code. Okay, so someone said country code. So like here is where it's like this is like stored in that O2, and essentially what that if does is check if you're coming from Russia or Belarus. So if you installed it on a machine that resolved to that IP geolocation from these servers, that's the only case where the whole thing applies. And if you're not, nothing specifically would have happened to you. Okay, understand the whole protest war here. But again, then there's like this loop within a timer, within this if statement check that goes ahead, use the fs core module to write a file to all of those files in those paths, which let me remind you, it's essentially the entire operating system, file system, right? There's a slash and everything else. So it writes all of them, and yeah, C2 string is the following. Every usage of this library starts a timer, replaces all files on disk with heart emoji. That's what it does. We have the moment that we saw this thing was like happening, on that specific, date and time. We've actually put all of that into a container, it's kind of like a sandboxed place. And of course, like some of the stuff we have actually edited the script to like not do anything malicious. We have simulated the IPs and everything as if it was coming from those kind of installs, and kind of like gave you a debug log of like seeing what's going on. And it did essentially mess up the whole file system when it was running. So let's see more. This actually evolved. This is just the beginning of this whole thing. So March 7, right, version 10.1.1 includes the malware, but then there's like a new version 10.1.2 also gets published, also includes the malware. Essentially nothing just changed. They just went ahead and like bumped the version. For what reasons? I can't, I can only assume. We don't know. Potentially maybe it's for like driving more of those like automated bots to like suggest you to upgrade like the latest version. So in case if they had some kind of like found something in 10.1.1 or like that was delayed, then you'll get 10.1.2 just just after. So this was happening like very like hours away. Then March 8, they have removed the version from 10.1.3. Based on the chatter and what was happening on GitHub, like people found it back then in March 7, and like criticized the maintainer for doing all of those things. It still like impacted those amount of people that 10 was downloading, was getting downloaded for. And March 8 actually included released a new major version called 11 that includes Peace Not War. That's a module that they created. Peace Not War, again, what is that? It's like, why would you do it? So here is the README of Peace Not War. These serve as a non-destructive example of why controlling your node modules is important, blah, 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 non-violent protest against Russia's aggression. This module will add a message of peace on your user's desktop. Essentially, the moment that you install Peace Not War, that module, it finds out your desktop directory. It even does like cross-platform. It has a checks for if you're like on Windows. If you put it on like the desktop, you'll like see it immediately. You'll see like a pop-up there. It puts a text file there with a message with love from America .text and some stuff inside it. So this is what they decided to do. This is the good outcome of it, because this was instead of the other malicious thing that had the whole file wiping, file system wiping code. Okay, so they did that, and we looked at it, and it's like, okay, these are the versions of Peace Not War. You see, it's like these are like bots, like Snyk downloads this automatically to do security stuff. Others as well. This is rather significant, but it's at this point it doesn't look like something is going on bad with this module. Like this is just another malicious module in NPM. We hear about them all the time. But then suddenly there's a spike of downloads. This is like a tremendous amount of downloads to just get. So what happened that Peace Not War as like a module that we haven't deemed it as malicious, and if you go to the security that's Snyk.io website for the open vulnerability database that we have, because it's not exactly malicious, it's just unintended behavior. Like obviously if you install an NPM module, you don't expect it to literally create new files on your desktop and send you messages. That's really bad, but it's not malicious. So even though it's not malicious, that's really significant number. So where is that coming from? And looking at it, remember I told you there's a more stable version, which is version 9, which this was what a lot of projects used, really, really big projects use this. Okay, so they removed the whole malware from 10. They added it to major version 11, and I would guess that the maintainers here felt that they hadn't made enough impact. They felt, maybe we could make more impact, so they added it then to 2.2, which is a patch version, and released it. And the moment again that it is, these tell you a lot about how fast those NPM installs work, right? Really fast. You put something out of automated installs, build, CI, users, they'll automatically get it. This is a really significant number. So who gets this? So one person just came into one of the Vue projects, the big one, the Vue CLI, the core Vue project, which has a CLI to do views React, Angular, a Vue thing. So it's saying, right, I was using Vue CLI that uses Node Ipc, blah, 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 and I believe I had a serious security issue because I created a text on my desktop that made me, figure out that it was a security issue. So users actually get this. They are scared. They say that they want to scan their computers, even formatted, because they have no idea now that what happened before, what will happen tomorrow. So they've done this. A lot of people have acknowledged this, and this drives a lot of scare for the ecosystem. Not only this, this is how Vue CLI and how Node Ipc is inside. And remember, Node Ipc 2.2 had Peace Not War. 9.2.3. So. Okay, so that's one user. And then there's this person. Let's look at the timelines. It's all very, very fast. This is from Unity Hub. So another Unity, the game engine that you build games with. They have this Unity Hub thing, which is I think an Electron-based app, which there's even a demo of how all of this thing happens and why this user saw it. It's essentially a Windows thing. You go to next of an install, very regular thing process. And the moment you're done clicking finish, Unity goes it's installed. Then you see a pop-up of the desktop with love from America.txt. So again, shows you this is really, really weird unintended behavior that scares a lot of people off. And they went into that Unity Hub forum, and this user said it over there. So at the moment, it's probably kind of what drives you at this point is when this is happening in real time is, okay, we know this has happened, we found it, we've put an alert out, Snyk was monitoring all of these things, but also you're now starting to think of this specific maintainer doing all those kind of things, what else do they control, right? What other modules do they have? What could they poison, further? So we were monitoring all of those cases. We don't know of anything else that they've done. And potentially like Faker, there was a fork out of it, and there's a new community doing that. So this was a really important and significant, I think, learning of just seeing also what we haven't seen before in this kind of maybe malice intent, maybe different intent than happened prior. Like there's like the left pad incident, but it wasn't really in malice. It was like kind of like protesting against something. This is protesting, but it's also adding specific malware, the first one to begin with, the one that wiped the drives, and that did impact users. So we were really fast and quick to respond it. I think we were like maybe the first security company to probably have found, did the whole walkthrough, did a deep dive, understand what's going on, did the analysis, and put the thing out. So there was a lot of like media coverage, and like if you just Google the whole story, you'll see a bunch of maybe interviews and stuff like the Register, the Verge, like all of those kind of places. So let's leave those things alone for a second and just talk about maybe other kind of things that are happening in the ecosystem, not just specific NPM modules, but also kind of like it brings us to think of and understand with supply chain security, like why developers are now being targeted, right? Like we have a lot of power. If someone can Trojan us as developers, like my machine, I probably have like API keys to like different environments here and whatever, like different config files that are important. So like backdooring me or Trojaning me is going to be super lucrative for other people. And it's not a new concept if you think about it. There's this, if we rewind back to something like 1984, there's this article called Reflections on Trusting Trust, which was written by Ken Thompson. And not a very popular person maybe, but back then he already wrote it and described how he would backdoor something that in ways that you wouldn't expect them. So he went on, and this is not a long paper, but it describes how he did it. So he decided I'm going to backdoor the Unix, the C login program, right? If you do, open a TTY like a terminal to connect to your computer, or like just SSH in, that login program gets triggered, and that's what you get. So he added a backdoor to the login program, right? That he can always log in or whatever. But if you code review the login program, the C code, you could find it, right? So like they didn't really invent anything new. So okay, fine. I'll add the backdoor code to the compiler that compiles the login program. Okay, that's like a bit more advanced. And at that point, you're like, okay, but people code review the compiler code as well, right? Like, what else? Sure. So then he went on and compiled. Well, how do you compile compilers? You need a prior compiler getting built. So like you go ahead, you compile that one, and then the binary compiler that compiles the compiler, and that compiles the C login program, that is the process that actually spawns and gives all of those inherited backdoored code into the login program. And essentially, the idea here with this article, which by the way, all of that he actually did end up doing, but all of that was really to kind of like touch on the point that we're really talking about here, which is where do we put our trust? Because when we use open source, we trust like those hundreds of maintainers, those hundreds of collaborators, those we trust the NPM registry to be secure, to be available, to be on time, to be fast, to not fail, whatever. Like all of those are, we have to put our trust somewhere. And this is not about to say like don't do open source because you can't trust anyone, because otherwise you have to like build everything yourself. Build Spring, build the keyboard, because it was also built by someone somewhere. I don't know, Apple maybe have injected something. So it doesn't end. You have to put trust somewhere. And it's a good, kind of like reflecting back and saying, this isn't a new notion, but we take it for granted these days, right? Like we take open source for granted. So what happens when we do? Like, talking more developer tooling, and I'm not going to talk about NPM packages in a way, like we'll see, it's more like the tooling around it. So when you think about what is it actually, it's infrastructure, because that's always a really, again, lucrative part, because it's something we don't think about as like, hey, that's an open source thing, but it really is. So think about things like, I run maybe CodeCov. I have my tests in Node.js. By the way, CodeCov is a code coverage framework for other languages as well. So if you're doing Python or something else, you might be using this too. So I use code coverage, CodeCov for my code coverage for my tests. And you can use it by installing the NPM package for it, by using their GitHub Actions, by using their Bash script, which they takes all of your the output of like the code coverage standard spec, analyze it, puts it out, and says hey, you're like at a 90% branching code coverage or more, whatever lines of code, whatever you want to test. But they've actually went ahead and disclosed back in April 15 that they were compromised, specifically one of their assets, that CodeCov tool, the one that we all use, one artifact of it was actually compromised. And that's usually used a lot in CI. Like I personally have used CodeCov before, used that in CI, but it was compromised. Well, what happened there is someone was able to gain access to the Docker image, which you could use CodeCov again as like a Docker image thing. So think about how you build Docker images, right? For like specific tooling that you have, you might not be having using the best, the most needed best practices to build a Docker image. So someone went through all of those, I guess, Docker images of CodeCov, the company itself. They found a public base image of CodeCov that had a hidden Google Cloud storage key inside it. Not really hidden, but just like left over as one of the layers. You kind of like put stuff on the Docker image, you build more stuff. You can do RM on the image file, but it's still there as part of like, the whole layer thing of Docker, of the container image. And that's how they actually got access to the storage in the cloud where CodeCov put artifacts. So what they did 4 months before this whole thing got discovered is replace it with something else, some kind of like, backdoor Trojan thing that when you install it, when you use their, the modified CodeCov image thing, you actually get to run their malicious code, which looks at everything in your environment, directories, everything you have in CI, which by the way is like very, very sensitive stuff because CI is used to then, deploy, do all those kind of things. And that's what happened. And it actually just became apparent that this is actually happening when someone found out about it just by, checking the sums, the checksums of the CodeCov that they had versus what they had like on the website versus what they downloaded. So the fact here is like they actually hit a lot of companies that were hit by this kind of thing because a lot of people, developers and companies use this. Names, right? Like Twilio and HashiCorp and Monday, which we, by the way, needed to disclose it because they were pre-IPO. They had to like file this thing, so they had to like disclose it. So like there's a lot of interesting stuff of like how a lot of very big, giant advanced tech companies that use open source use CodeCov, and they've like, had to find out about it this way. And it shows you how it's not just really NPM packages, right? It's not a story of like one ecosystem or the other. It's all over all the time. Like we can't even cover, all of those cases that are happening. Part of the stuff that I do, as I told you like before, like some community stuff is I usually like go when those things happen, I actually go to the CNCF SIG repo, tag whatever, renaming it, has a supply chain incidents file. So it's kind of like unrelated to NPM or something. It's like a general one. So like, for example, when PHP, that team that developed PHP, they had running their own Git server locally, and they got essentially kind of like backdoored as well. So they then moved to like GitHub. When that happened, we went ahead and documented it there. So like I keep track of those things and try to update them there. But that's kind of like just an example. Like this is another example. Like it happens all the time. We just like, there's like too many stories of this happening. Well, what about VS Code? Like I told you before, I use VS Code. Anyone here uses VS Code? It's cool. Yeah? Okay, cool. So it's cool. What makes it cool? Extensions. Thank you, Adrian. I love you today. Because of cool extensions, we didn't prepare this. This was good. For example, here's one that gets downloaded when I took the screenshot 100,000 something times. So it's pretty popular. It does markdown stuff. So this extension that I might use because I want to like edit readmes, but before I upload it to like GitHub or something, I kind of like want to see a preview of how that looks. So I might go ahead and again, like Adrian said, install the extension, enable it, and that works. And it's really cool. It's cool until someone finds something bad with that extension. So this wasn't a malicious case, but it's super interesting. And I'll show you, like, if I have a video prepared for this, like show you the whole demo thing. But what happened is we've got Raul and Kirill. They both work at Snyk at like the security labs and research thing. And they had a research done on the VS Code marketplace. And what they found is there are a bunch of not modules, but extensions on the VS Code Marketplace that not necessarily are malicious, but they have vulnerabilities, like literal vulnerabilities in the code of the extension. Now, if I told you this before telling you about like what's going on here, you would tell me, I don't care. I don't deploy this extension to production. It literally stays on my machine. If it has path traversal, if it has SQL injection, what the hell do I care? It's literally running on my machine. Most of the cases, maybe you'd be right. I don't know. Like you can do your own triage and figure out what what works for you and what risk level you want to accept. But they have shown how this isn't the case. So they found several of them. I've named one that is like very popular use case, which I've even used like a Markdown before myself. But there's others, and there was one like a LaTeX one that gets like 1 million downloads or whatever, like even more popular, that they have vulnerabilities, okay? So one of the vulnerabilities were a path traversal one. So for example, for this Markdown thing to work, behind the scenes, what the extension does is it takes your code, but for you to like, go to render this localhost 8080, it actually needs to spawn a local web server, exactly. And when you code that local web server with a path traversal vulnerability, that's bad. So not that they intended to do this, but they didn't realize it. So they found ways, and that is what the research actually shows. Like again, a deep, by the way, really interesting one, because the payload to like do the whole what I'll demo in a second, the whole exploitation here isn't that straightforward, because if you try to go to from one website, example.com or whatever, to localhost 8080, you have the issue of cores and different things. So they used a really interesting technique of how to actually access and exploit this. And what I'll show you in a second will show you how they actually gain access to any file that you have if you're using this extension. VS Code is running in the background. Any file that you have on your PC, simply by clicking a link. This is one click, right? You know how you also always read about those like I don't want to call them malware, but like about those companies in the news that do offensive security, and like with a click to like they send you on WhatsApp a link, you click on it, that's it. WhatsApp to your phone, everything is gone. Like they know those stories from CNN and stuff. Okay, so essentially this is what it is. All I need you to do if you're using this is to click that link, Twitter comment, Reddit, whatever, I can send you this. You click on it, and I can access everything. And this is what I want to show you for a sec. So let's see if my video here works. Okay, so what you'll see is VS Code, Markdown, the browser, which is kind of like dummies the user of what they do. And Kirill has a bunch of terminals essentially to simulate this whole thing. He actually shows that he has he doesn't have the file that he's trying to get. He'll do like an ls, show you that it isn't there. He'll start a web server, and he'll use ngrok to like make that whole story as if it was really within the internet and not something localhost. So here it goes. So here is the file, shows you it's a regular process, starts like a local server, ngrok, and shows you it has 3 files only. None of them is like the secret key. Then the user went and clicked on this link, right? You were able to Trojan them and do this. The moment that you did it, I'll stop it here. The moment that you did that click on the browser, which was like really fast, you could imagine the whole phishing attempt going under, so you wouldn't even suspect it. Now you have the keys, where is it? Cat keys.txt, right? So like now I basically have everything there. I take it back a bit. I'll run this again just for a sec. Downloaded the file. which somehow got triggered. That did the whole path traversal in a script thing. And then, again, keys is available on. So basically, he was stealing from himself in this case, some key file that he wanted to. I can steal anything, and some file that are really sensitive, I know them in advance. Like I know to steal .npmrc, because if you're a maintainer of some project, I get your .npmrc, or potentially if you didn't enable 2FA, I can now publish packages to your repository. I can steal environment files, the whole etc password kind of like joking stuff, everything that I want. And this is one example, but other cases that they found, like the LaTeX one, that was remote code execution. So there's also like a cool demo of that, of like the moment that you clicked on a link, you'd immediately see like the calculator pops up. So like basically we're able to like run that command remotely from the fact that you were just like visiting a link. So super interesting. I highly recommend reading this for knowing how it works. I don't know if you know this. Did you know about this one? No. So I'll tell you something really cool. We later on opened the code for some of these extensions, not all of them because there was a bunch of findings, but for Markdown and for the LaTeX one with Snyk code. And you could see Snyk code actually shows you, like as a developer, if you had used it, that it told you, hey, there's like a path traversal here. So it kind of like goes to show you that you have to be secure if you're doing like extensions, right? You have to do secure code practice if you're doing extensions, because here's what people find like 2, 3 years, 4 years after. Insecure line of code that potentially puts users at risk. So thank you for building Snyk code. So I love it. Okay, so some preventative measures of like, we talked about a lot of stories. I'll give you some kind of takeaways of, what to do if you need to like try and lower the attack radius here. So first of all, we talked about the fact that if you do npx something, that's essentially like curl some website stuff and piping it to bash, right? Like that's really bad. That every npm install, every npx install essentially gives any users that run it access to run whatever command the maintainer wanted. Not just the maintainer, but if it has like transitive dependencies, as one of them have npm install, they also get access. So like think about this is like super crazy, because me as a maintainer, if I use open source packages, like if I in my project, I'm also not going to code review every single line of code and new version releases of all the 40 modules that are part of my tree. It's impossible to do it. It's really impossible. So instead of doing those kind of things, and not just typo squatting and malicious modules, but everything else, I really, 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 really recommend do this. NPM has this -- ignore scripts. I'm giving it here just like because it's like a good example of showing how it is. But you can also, for like developers, like they don't forget to do it. You could add it as like the .npmrc, like the config file for the npm package manager. Put it not even in the not in the current directory of the project. Put it somewhere at the top as like a global one, and then wherever they work, when they do npm install, it ignores all of those automated install scripts. Now, caveat is 2 of them. One is that functionality is a bit broken, the -- ignore, in prior version to, I think, npm 8, maybe even 7. Okay, it's broken in a way that when you supply it, and you even go to your project and you do npm run build or run test, like build the test and everything else, it doesn't do it because you told it to ignore scripts. So the npm 8 version onwards fixes it, so like it doesn't run the installed stuff, but it does allow you to run your own project scripts, okay, which is what we want. So that's one caveat. The other one is some packages, like justifiedly, do need to like run scripts when they get installed. For example, Node.js is a native module built in C, and it needs to be compiled when you install it, right? So you have those cases. So I am going to say do security as secure by default as you can. Always have this. When this fails for your team and your developers, go ahead, check what's going on with them. Maybe you can add an exception rule for one of those modules, right? But you definitely do not want to allow everyone to just run whatever commands they want on your system. Okay. The other thing is don't do blind upgrades. I've seen and talked to many developers. I have some good friends that on the CI, this is what they do, okay? And they tell me, I want to know all the time that my code is always up to date with everything else, nothing gets broken, whatever. I'm not going to say correct or incorrect. I don't think you should do it. But I'm telling you, essentially, if you do this, you're exposing yourself to all of those other threats that were happening. Think about what we've just learned about Faker, okay? If you had done this, you've been getting the Faker, bad version. If you had done this, you'd been getting the caller's bad version. If you had done this, you had been getting Node Ipc bad version. Okay, all of those. Why? Because you can't be on the bleeding edge and expect everything to be amazing and pretty. I'm not talking about functionality, I'm talking about malicious threats. So upgrade when you need to. And what is that? Use smart automated upgrades, okay? There are a lot of bots. Dependabot has one, GitHub and stuff like that. Use whatever you want that works for you. I'm not going to tell you to use one vendor or the other. Whatever works, that's fine. I will tell you that we have looked at all of those cases in the past at Snyk. Not sure if you know, but Snyk has like the same thing of like an upgrade, unrelated like security issues. It has like upgrade of like all of those dependabots. But the cool thing about it, that's different from everything else at Avsen, is we actually studied all of those. Remember I told you about the reference to event stream in the beginning from 2018? Back then, we looked at all of those malicious cases. There was a bunch before that too. And we kind of like studied like the timeline, like how long does it take the community or the maintainer or someone to like find this? And so we said, like, unless this is a security, fix that you need to get it right now, unless this is the case, for everything else that's just like, functional upgrade, you just want to upgrade the versions, we are going to delay the upgrades that you get to the bot, from the bot to the PR by 3 weeks. Okay, this is like a very reasonable time for the ecosystem, everyone to like, have eyeballs looking at it, to vet it, to potentially find it. Plus, you can't really say that you're like using old legacy software if it's just like 3 weeks old, right? So like that's okay. So like that's a very kind of like balanced upgrades, and that is what I suggest to do. It's whether you want to do it manually yourself with some other tools, that's fine. We do it already automatically, and we do it because of that. So we kind of like factor this in. This isn't new, by the way. This is like existing for like 2 or 3 years already. Other thing that we should be aware of from all of those stories. Understanding package artifact disconnect. When I say that, I basically mean, if you look at the two sides of this equation here, your NPM registry is not the same and doesn't reflect at all what's in the GitHub code registry, the GitHub repository. Okay, and this is not just NPM. Most ecosystems, Ruby, Gem, whatever, they work the same way. Okay, what I mean by that is, remember I showed you before, Faker, they like went in and pushed a forced commit that nulled the whole code on GitHub, right? That didn't do anything for NPM packages. Like it's disconnected. That's not even the same users. It's like even the users who may control packages getting published and users who have access to like merge and push code to the GitHub registry, different people. So think about it and understand that those are like two different things, and don't expect even like the tags to be the same, like latest here, latest there, and all of those things, even like the version tags. So yeah, if we had looked at it, we may have not even found it. Dependency confusion, it's a long one, so I won't get into too much, but I will say 2 things. First of all, I did get the reference at the beginning that like we did find a dependency confusion attack happening like in the past couple of weeks on NPM. So like that's like a really recent blog post if you look at it on the Snyk website. But like okay, I'll try to like summarize it really quickly. But essentially, dependency confusion is the following. Think about the fact that if I'm a developer working at Microsoft, I might need to install this really legitimate package called, not this one, but it does have a similar name, Azure Core Tracing Sample, blah, 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 okay? Because I need it. It's something that for my development platform, whatever, blah, blah, blah. So I need to install it. And I follow some docs and whatever, and I do NPM install this thing. This, however, is not what I was intended to install. But not only the fact that I didn't intend to install it, there's an inherent way that the package manager work and some proxies behind the scenes, like Artifactory and like Verdaccio, etc., in the way that they resolve software packages specifically. So if I have a version internally called Azure Core Tracing Sample.js, okay, in my internal private repository of Microsoft, the building, the website, the IT, okay? What happens is the moment that I do npm install, okay, this is like a private package. It doesn't exist on npm, okay? If you do it outside, you don't get it. I only get it because it's hosted internally within the Microsoft infrastructure stuff. If I did that, it goes, the logic for it, the way that the package manager works is, it actually does query the npm registry, the public one. It asks if this exists as a newer version, and if it does exist, it pulls it instead of the one that's hosted locally. And that is a dependency confusion thing, and it's related to a bunch of contributing factors are here. The package manager, the proxy in between that is like not configured correctly, etc. But essentially that allows someone to then, if they find out which private packages you have internally, which is, by the way, there's like some interesting ways of finding this way, but if they can, all they need to do is release this exact package name to npm. As we said, it's free, it's open, no one really looks at it anyway, and I can just release whatever I want. So I release version 9999.999, you get the point. It's like the most recent, the most major, latest version, whatever, everything catches. The moment the next person does this in the IT, whatever, the new employee, whatever, in Microsoft, this doesn't get installed what they want. It actually goes and fetches the new one from the public registry, okay? This is a case that's called dependency confusion. We learned about it last year by Alex. He and a bunch of people did a whole deep dive on this security research. They really went in and like hacked into those kind of companies. They actually received, I think it's Microsoft, but I'm not entirely sure, but there was like, I think they did like receive the highest bug bounty amount, like a 40K bug bounty for like this finding and disclosing this. So I think it was from like the Microsoft program, but this was real. Like they actually managed to get to all of those systems by just finding the private packages that they are using internally and publishing them outside. And this is what we also found with Snyk like a couple of weeks back. So I really like recommend reading up on this. It's super important. But how do you mitigate against this? Okay, so back again when that happened, me and Kirill went up and we said, hey, be careful of npm updates, because by the way, if you did that, that is also like a very prone way to get the latest packages. So the moment you did this, you're done. I got it here, but I don't remember if I think it was the Azure program from Microsoft, but I'm not entirely sure. So I'll check on this, but this was nice. So me and Kirill went out and called this thing called Snyk, which honestly I don't remember now what's the abbreviation, but I think it's so now you're not confused, because Snyk is so now you know. So like we kind of played on this. But what it does is it looks at your actual Git. It's pretty smart. It looks at your actual Git repository, like your whole history. It tries to find deltas in time between when you added a package and at that time if it already existed on like the npm registry or not. And if it's not right now, this is already like red flags. And so it does like a bunch of like heuristics to tell you, hey, you know what, you're using a package, you have it like on your manifest, but the namespace for it is free on npm. You should like register it right now, because if you're not, someone else might register it, and like a bunch of other heuristics. So you could use that in like CI or something and like make sure that your developers don't use something like a new package that they published, but it's the namespace is empty and anyone can at any point like Trojan you. So you could use this, open source of course, and everything else. Yeah, I did say this one before in terms of like the updates, but it also applies to like just don't install blindly stuff. What do I mean by that is sometimes we just go to like, developers converse on Reddit and Twitter and stuff like that, and they say, hey, this just did like a great framework and whatever, and you could just install something that you have no idea what it actually does. So instead of using the currency today that developers have, which is downloads or GitHub stars, which is an okay currency, but it's not the whole picture. And kind of like what you want to look at when you use a package is the package health score, right? You want to figure out not only whether the package, this is like not related to security issues at all at this point, right? The story is I'm using a package, but maybe it's deprecated. Maybe the maintainer hasn't like done anything with it in the last like 12 months. Like maybe if there's like, if you scroll, you'll see like security, you see maintenance, you see commits, you see popularity, you see several kind of perspectives of the package, how healthy it is, and it kind of helps you figure out if you should use it. You know, maybe it's getting deprecated, maybe it's getting abandoned, maybe you should like start using something else if you want to find alternatives, and so on and so on. So an interesting tool to give to your developers, help them find good packages. The other thing that's also not widely known is a feature that exists today in NPM, but it was actually before that existed, pioneered by the PNPM package manager and the Yarn package manager. There it was called resolutions. For NPM, it's called overrides. So think that right now you have the case of Node Ipc, which, if you remember, that was the malicious case of like wiping all of your disk drives, right? That this was like really, really severe. So if this was happening right now for me, like the first thing I want to know is if I have it, right? Like I want to know if I'm infected or not, at the very least. You could do npm ls node ipc and you could maybe find it, but it wouldn't help you, because maybe to mitigate the problem, it's brought in by a transitive dependency again. So like you have zero control of that. It's the other maintainers in the chain of the tree that actually say, get the latest package, get the latest package, get the latest package, and that's how it flows to you. So because you have zero control of that, NPM has this new feature in also exists in like NPM8, so like use that because of the ignore scripts fixed functionality, but also because of this. And it gives you a way to say, regardless of where this is in the tree, regardless of what maintainers said and what I have in log file, whatever, I want to tell you that when you do npm install, if you find Node Ipc greater than this and lower than this, always pin it to that version. This is regardless of the tree. This is regardless of the log file, okay? This kind of like helps you do the current workaround and pin the versions across the tree, which you can do without this, because the package manifest is only direct dependencies. Transitive you don't control. All right, so I know this was long, hopefully fun. I know a bit scary, but I hope fun, and some stuff is new and you learned. So like really, I think that we're going to have more software in the future. Open source one probably is what we're going to see more. It's some kind of stuff to think about, right? Like, are we going to have more of that? I guess we are. That's not. I don't think this is going to stop. I think it's going to grow. We're going to adopt more of it. But I think part of doing all of these tools and education and writing and doing all of those kind of awareness sessions is making us more aware of all the risks that actually happen there. So, figure out who do you trust, put some guidelines there, and that's it for me. Like, thank you so much for being here. Thanks. Any questions?
So this is about Node in particular. So
yes.
Does dnode bring any, let's say, betterment to the situation? Like, does it improve the situation in some way?
It does in some ways, and in other ways, maybe not so much. It does have this kind of like sandbox internally that you could say like maybe this module or this node process can access the file system or not, but you have to probably do that consciously and configure those things. Other cases where it may be a bit the Wild West again is you could actually, and this is not just this is like the whole spec of VSM and stuff like that, you could actually say, I want to use a package and give the whole like GitHub URL for it, like you do for Golang and stuff like that, which is also a bit weird in my kind of like thinking about it, because I think like it sounds decentralized, it's nice, etc., but the centralization of NPM sometimes helps you. For example, if you use a package and tomorrow like leftpad happened, like in 2016, leftpad is a story of like a package, 11 lines of code that just padded strings on the left from a text. The maintainer went one day, removed all of their modules, 250 of them, including leftpad. They didn't intend to, but they did. And leftpad is like was downloaded like millions of times by like Webpack and Node.js and Babel and like really large projects, and it broke all of those builds. And so the ecosystem, the NPM registry learned that this could happen. Like they haven't thought about this before. They said, oh, okay, let's not allow maintainers to like remove their code if people are like millions of them are dependent on it. So the other case that would happen with all of those like requiring, code from GitHub just straight up by the repository is tomorrow if you need my code, I can go ahead and delete my repository, and then you're stuck, right? Like, what will you do? Look for, archive it, or, it also breaks your build. We're talking about Vox days before. I was actually talking with some Golang developers there. They said, like, Golang was, great language and all of that, but they had like 2 cases, in the whole 2 years that they've using it, that were the repository that they were, using the code base for the Go project. To 2 cases where the repository was like gone, and they needed to like do a workaround. So it's not a big thing, but it's a disruption, and it's something you don't expect. So I haven't used beyond that. I haven't really used Deno more than this. This is just like perspective that I can share from like my limited experience with it, but hope it helps.
I have another question.
Yeah.
The first one is, if we are using GitHub for all of those dependencies, should we fork all of those projects and then start?
No, because it's more overhead.
Yeah. It's something that can be on my mind. The actual question is, of all the programming languages that you mentioned, like Ruby, Go, Python,
which is the more secure?
Which is, I wouldn't say the more secure, but at least the one that is doing the most things right. Let's put it this way.
It's hard to say. I don't have insight into all of them also to like judge this very well and like balanced. But I think like we're seeing different cases of security issues in all of them, right? Like Spring for Shell and Log4j and Java, which existed there for like, it was like 10 years hidden, right? Or whatever, 6 years it was there, like no one found it, and then someone found it and talked about it in Black Hat, but then they ignored it, and then it's still like vulnerable, blah, blah, blah. So would you say like, hey, those developers in Java, they really don't understand how to build secure code? I don't know if I can judge it like that, but like it shows you like one of them. On the other side of things, like you do see extensions in VS Code, right? Like people write and have no idea about like path traversal and how, again, it's like a basic thing, but people don't think in those cases, in like those terms when they write code, making it secure. They're not even aware of those vulnerabilities. So there's like the vulnerabilities, and then there's like the ecosystem, which is part of the supply chain security. And then there's like the registries themselves and what they do. I would like to think that NPM as a package manager, seeing how you can like manage packages in Go and Python, like edit files, which is crazy for me. I think it kind of, it's very advanced. While it has a lot of like, left pad and these kind of stories, it's still like a very advanced package manager. There's like a lot of experimentation. We learn a lot of things. We fix them when we can. Right now, what NPM has been going through, for example, is remember the stories about 2-factor authentication and like hygiene of like the packages, like someone doesn't compromise another maintainer. So they have understood it. They went through a process of like identifying the top most, 1,000 popular packages, which by the way, those kind of like reach everyone. And they went in and and then they like staggered them and said like, okay, let's go ahead and reach out like the top 100 maintainers of those most popular packages and get them to enable 2-factor authentication, like all of them. Then they went in and did that for like the 500, and it's going to go and go and more. So I don't see it happening in like other ecosystems. I think as hugely advocated as it is for like NPM. I think there's like, we understand the problem. It's not an easy problem to solve, but I think like for the JavaScript one, sure, you could laugh at all of the stories, but I see that we always like to learn from them. We always like do something. We build the tools. We kind of like give the community some ways of mitigating them. There's always going to be the problem, I think, in general of like awareness, like education, and like telling developers, engineers, and ops people like what are the best practices, what to watch out for, how to apply them. I don't have a best answer for like which is the best language. Sorry.
Okay.
Cool.
Any other questions?
Yeah, you are recommending to use packages that are at least 3 weeks old. Is it based on some kind of statistical data? Or
Yeah, it is. It's not just packages, it's package versions.
Yeah.
Yeah, so the automated upgrade that you get for like a package that you use, you will get an upgrade suggested to you after 3 weeks of that new version being out. And that is based on statistical. There wasn't many cases to say it's statistically significant, but like I think 10 cases of malicious packages that we've seen in the past. And they happened, Event Stream was the one that lasted the longest, like 3 months until people found it. But besides it, being an outlier, most of the issues were found pretty fast, between weeks, so, or even like days or hours. So I would say waiting like 3 weeks to like get an automated upgrade from a bot and merging it, that's a very balanced way of like staying up to date, but not like the bleeding edge.
Okay, but this time-based trust
Yeah.
is not something that you can use with overrides, and those are only based on the version of the package?
The NPM overrides feature that I was showing. I think that Miles Borins, who manages the team at GitHub for NPM, he was sharing some data about only allowing to install packages based on like specific time ranges. I honestly don't know if that's like supported through like transitive dependencies and stuff like that. So you'd have to like look at the docs and see what it says. So with that, I don't know what to say with overrides, but the bot, unrelated to where you have the stuff in the tree, will always give you upgrades that are delayed by 3 weeks. Sure. Good question. We should look that up as well. I'm interested now to see what the doc says.
Cool. Then if there are no more questions, thank you so much.
Thank you all. Thank you all for being here.